This video is a discussion of the review for Exam 2, problems 16 through 20. A researcher is studying Murex contamination in farmed salmon. He first found a 95% confidence interval for the mean concentration to be between 0.0834 and 0.0992 parts per million. The environmental agency sets a limit of 0.08 parts per million to be considered safe. So let's think about it. All of the numbers in this confidence interval, in this 95% confidence interval, are strictly larger than the limit. So the 95% confidence interval lies entirely above the 0.08 parts per million, which is evidence that the concentration is too high. It's too high to be considered safe because the interval is above the limit. So it's too high to be safe. Check our answer. A researcher investigates whether the mean cholesterol level for those who eat frozen pizza exceeds 220 milligrams, the value considered to be a health risk. The confidence interval for the mean is 215 to 232. Well, the particular pizza in question is 220, and it lies within the interval. So it actually contains the figure in question. And so the mean cholesterol level for those who eat the frozen pizza does not indicate a health risk. Check answer. So we have 520 seafood samples, and they contain a standard gene that identify the species. 81% were mislabeled. So the percent mislabeled is 0.81 out of 520. And then we're going to have to construct a confidence interval. So I jotted those two figures down. I am going to have to figure out the number that are mislabeled. So I'm going to have to pick up my calculator, and I'm going to have to clear this out. And I'd have to figure out 0.81 times 520, which turns out to be, as a whole number, 421 if I round it to the nearest number. So let's see, we're going to do question help, StatCrunch. We're going to do statistics, proportion, one sample with the summary. We want a 95% confidence interval. So there were 421 out of 520 that were mislabeled, and we want a 95% confidence interval. We're going to jot down the boundary values of 0.7758 and 0.8434. And we're going to scoot this over and go back to our problem. So we want this in a percent. So I'll have to move the decimal point and round it to one place. 77.6, and 84.3. What does this confidence interval say about the seafood? I'm looking for the word confident. We are 95% confident the interval captures the true proportion that is mislabeled. Is the government's spokesperson's criticism valid? Let's see, the government spokesperson says the sample size is too small. Well, no. As long as the conditions are met, they can be generalized. And we're going to check our answer. All right. Let's move on to problem 19. A philanthropic organization is sending out 100,000 mailings, and from that they received 4,884 donations, and we want a 90% confidence interval. I jotted those figures down. I'm going to go to StatCrunch. I'm going to pick up Stat, Proportion Stats, one sample with summary. The number of donations was 4,804 out of 100,000. Got the right number of zeros in there. And we want a 90% confidence interval. And compute. So I'm going to jot down several decimal places here, 0.0477 and 0.04996. And we'll scoot this aside and go back to our problem. And we want it in percent form, and we want it accurate to 2 decimal places. So 2 decimal places in percent form would be 4.77, and got to be careful of the rounding here. When that gets rounded up to actually 5. Gets rounded up to 5.00%. So the confidence interval you found, is the proposed rate plausible? No, because 5.1 is above it. Let's check our answer. That's good. You do have to be very, very careful on this 2 decimal point rounding. So what the interval that StatCrunch gives you, you want to record it to 4 decimal places, since you're going to have to convert it to a percent. Final problem, a relationship between fat content and calories for burgers. We would like a scatter graph. We want a correlation coefficient and a description. So I'm going to click this icon. I'm going to open the data in StatCrunch. There's the data. I'm going to go to Stat, Regression, Simple Linear. The predictor is the fat. The Y variable is calories. And I think that's all we need to do. So I know later on it's going to want the correlation coefficient. So I'm going to jot that down, 0.955. And that is 3 decimal places. And then I'm going to go over here and look at the scatter graph. So I'm going to scoot all of this aside and see which of these looks correct. Well, B does not look correct. C could be correct. D does not look correct. So if I compare my graph with C, it looks pretty much on target. So I'm going to pick C. We jotted down the correlation coefficient, which was 0.955. And now we need to describe things. I would say that's very close to 1. So there's a strong positive association. The higher the fat content, the higher the calories. There's a strong positive linear relationship. Check our answer. Good. That wraps up the practice exam 2.